All right, so here we go. We're reviewing for algebraic manipulation number 2. By the way, this category of testing, algebraic manipulation, is the most retaken kind of test, as in they are the hardest kind. We already had one of these, and of your 3 tests you had before we had the cumulative, that was the hard one. Okay, well, now you're having another one, so pay attention. It's not like it's impossible. It's that kids are in the middle of a problem and they screw up. They screw up a negative, or they screw up, they don't distribute something, or they forget how to combine like terms, or they forget how to handle fractions and fractions, or the little stuff. All right, so let's go through a typical problem. This is a function. F of x is x minus 5 underneath the square root. Do you remember what that little f with the little minus 1 means? An inverse is this 3-step process for solving that. I'm going to pause for a second and let you try to solve it. Remember, the first step is you make it y equals. Second step is you reverse x and y. See if you can do it from there. I'm going to pause for a second while you try. Okay, in case you're stuck, I want to get you going without too much delay. All right, so first step is you make this into y equals square root of x minus 5. Then you make it x equals square root of y minus 5. And then you're trying to solve for y. And you got to keep repeating that to yourself as you go through the rest of this. I'm trying to get y alone. All right, how do you get the square root off of there? You square it. Squared. So this is x squared equals, and when you square both sides, no big scary things happen like absolute values are needed on whatever. It's just simple. You square both sides, that's easy. It's square rooting both sides that gives you an issue. All right, and I'm almost done now. I just have to add 5. X squared plus 5 equals y. Raise your hand if you had that one right. Awesome. You know how to make a simple inverse. That would be like an R2 level inverse. Then, what is the domain and range? The domain and range of the original one is the one you care about. And then, once you found that domain and range, then you want to do the inverse based on that and just reverse them. Like the domain becomes the range, and the range becomes the domain. So figure out the domain and range of the original function I gave you. Don't ever do it off of the inverse you created. Don't use this for doing the inverse. You will get it wrong. So when you're trying to find the domain and range of the inverse, find the domain and range of the original one. And if it's one you can draw a picture of, I strongly recommend it. Like that one, you should know what it looks like. It's the little ramp thing, except it's moved where? Right 5. So it should look kind of like that. So then when you find the domain, oh, that's easy. Domain's left to right. It starts at 5 and it goes to infinity. And the range, 0 to infinity. Because the lowest it goes is 0. Okay, there we go. And then the domain and range of the inverse are just the reverse of that. So the domain becomes that range we just made, 0 to infinity. And the range becomes the domain we had, which was 5 to infinity. Raise your hand if you understood that. Okay, good. Let's move on. Here's a harder one. Find the inverse of that. And this one's going to involve that algebra we were talking about, where a lot of kids will stumble at one point in solving of this puppy. Because you'll reverse x and y, and then you have to solve for y, and a lot of people trip in there. See if you can do it. I'll pause while you try it. Okay, I know that's probably not enough time to finish, but I'm going to start anyway. You guys can keep finishing if you are okay. If you're lost, then watch me. All right, this first step is to just make this a y. The second step is reverse x and y. So I'm putting an x here, and I'll make those 2 x's over on the other side into y's. Okay, now your next step is whenever you have fractions in a problem, get rid of them. How do I clear the fraction? I multiply by y plus 2. That way, I won't have that y plus 2 anymore. Always do it in parentheses. Parentheses are big in this unit. We have so many cases where if you don't use parentheses, it'll screw you up. Yx plus 2x equals 3y minus 5. And then this, I kept saying you should repeat yourself over and over. What are you trying to do? Get y alone. Good. So I'm going to subtract 3y from both sides because I'm trying to get the y's together first. This y and this y need to get together. So I'm going to get this over to the other side. So yx minus 3y, I'm going to do a dangerous thing and try to do 2 steps at once here because I'm running out of space. And I have negative 5 left there, and then this is going to be minus 2x. Okay, so I move the 2x to the other side and the 3y to the other side. Now I have y's in both of these. Do you remember what to do? Factor out the y. That's a key moment where either you know how to do that or you don't. And then the last step, it's just to get the y completely alone. It's being multiplied by this, so you're going to divide it by x minus 3 in parentheses, just to be safe. Y equals negative 5 minus 2x all over x minus 3. And all it would take is for one negative to be wrong in that, and you've got it wrong. So be careful. Okay. Now, to find the inverse, the domain and range of the inverse, these, I am not going to look at that. I know it's tempting to. Don't. You will get it wrong. You go back to the original and look at that. Find its domain and range and then flip-flop them, because sometimes the answers will come out different. So you really need to go back to the first one and do it. Okay, so then the domain of that thing is everything works except, close, negative 2. Okay, so I would say everything works except negative 2. Here's negative 2, can't be that. All right. Now another way to write that is from negative infinity to negative 2 and union with negative 2 to infinity. If I need you to write it that way, I'll say that. Either way, either one of these things explains the same thing. Okay, then the range. The range is the harder one. The range on these, you have to ask yourself, the only thing that stops this kind, fraction kind, from going from negative infinity to positive infinity is the horizontal or the horizontal asymptotes. And how do you get the horizontals again? Bob will tell you why. Is this a bob? No. It's a same on both. It's a sob. Okay, because it's about the degree of it. This is not a bob, not a bigger on the bottom. It's not a bigger on the top. It's the same on both. Same degree on both. They both have a degree of 1. Okay, so since it's the same degree on both, it's the same on both, and the ratio is 3. 3 over 1. Okay, so then it would be y equals 3 is the one thing that stops it. So the range is everything except the one thing that stops it, which is that asymptote line. 3 can't be 3. You get that? Yes. What if there was no y? Oh, you mean there was, oh, if it was bigger on top, then there's no asymptotes, which means that the thing will go forever. Infinity, negative infinity, positive infinity. Yep. Yes. If the domain is just whatever makes the bottom crash or square roots. But the range is not about the bottom. The range is about going from negative infinity to positive infinity, from how low to how high, and the only thing that stops you there is horizontal asymptotes. So every time you're doing the range, you're doing the horizontal asymptotes. So you're looking for those. And if there aren't any, then that would mean everything would work. All right. Next thing is to reverse them. So the final answer for the domain and range of the inverse, this means inverse, the domain becomes the range. So this just becomes the 3, can't be 3. And the range is this one, which is can't be negative 2. And again, if the directions on the test say to use the brackets and parentheses, that's called interval notation, then you should have to write it that way, from negative infinity until negative 2, union with negative 2 to infinity. All right, moving on. Proving that things are not inverses. What's that thing you have to prove? F of g of x is equal to f of x, g of f of x, which equals x. So I would do this. And I would draw a line like this right down the middle. I'd find out both of them, and they both better end with x if you did it right. Okay, give it a try. I'll pause while you try these. Okay, so here's what you do. You take the g and you put it into the f. That's this one going into this one. Both places, notice, you got to have it in both places or it won't work. 2x plus 5 in parentheses minus 5 over empty spot. Really should have started with empty spot, but now I got it. There's both my parentheses. Okay, now, do you remember how you should cancel these in the right order? Because if you just go like this and this, I will not give you the credit. Okay, you got to do it in the right order. All right, so what has to happen first in a fraction? There's big parentheses here, which means this is forced to be first. All right, making sure I copied everything correctly. Yes, I did. Okay, so then on the top, I can cancel those two. And what's left? 2x over 2x plus 5. And then some people thinking that, oh, well, I know it's supposed to come out to x. Well, I'm just going to like force this thing to work, and I'm going to go, that cancels that, and the answer is 5. Wait a minute. No, that's not right. I'm going to cancel this and leave they make up some baloney and then say x. Okay, I will be watching for baloney. I have to grade this part of the test really carefully. Does that 2x cancel that other 2x? No, it does not. You can't do that. Okay. So bottom line is this one does not come out to x, which tells you what? They are not inverses of each other. Unless I'm doing something wrong. Does anybody see a way that it could cancel out and become an x? Because nope. Can't cancel these two x's. Illegal. Breaking rules. Same reason you couldn't do this. Do you remember me talking about how you can't cancel those x's? Can't cancel the two x's either. No, you cannot cancel the 2's either. Same logic. There'd have to be a 2 in everything. If this was a 2, then you could cancel a 2 from, as long as there's 1 in everything, then you can cancel stuff. There'd have been a 2 here, then you could have canceled the 2's. It still wouldn't come out to x, though, which is what we wanted it to. So bottom line is, since it's not coming out to x, I know this thing can be, these are not inverses. Don't have to keep going. That's correct. But I will tell you, more times than not, they are going to come out to be inverses, and the point is more about proving it in here, doing it in the right order. Okay, let's do another one, and these actually are inverses. I'll tell you they're inverses. You know they're supposed to come out to x. Try it and make sure you know the right order and everything so that they come out to x. I'm going to get going on this and put the g and the x, this one into this one. So I have 2 over parentheses plus 3 is really that's how I should start. 2 empty spot plus 3. That's this thing rewritten with an empty spot. Then I'm going to drop in 2 over x minus 3. And this is where, do you know the right order? Can you just go like this? No, you cannot. You'd get it marked wrong if you started with that step. Why? Because the order of operations is important. And multiply and divide comes before adding 3. That'll be later. Right now I have to do the multiply divide, and that's a divide. So we should do 2 over, and you flip and multiply. If I wanted to make this a multiply, I should make it 2 times, flip that other one, x minus 3 over 2. There we go. And now my 2 can cancel my other 2. I'll show you that again. That was a flipping fraction. Instead of this divide right here, I'm going to say 2 times, flip it, nope, and now I can cancel them. You cannot just do this. Not okay. You don't know that that's true. The only way you'd know it is if there was one on top and one on the bottom, like this. Then you bring down this plus 3, and then you can do the add subtract last. That gets done last, and then my answer does come out to x, just like I want it to. Question? Okay, on the other side. Other side, I put in the f and the g. So this goes in here. 2 over empty spot minus 3, and then it's 2 over x plus 3. All right, on this one, I can see how kids could get confused by this, because they might say, well, don't you have to do the divide right now first? This divide here? No, you should not. Why? Because there is big parentheses here. And what comes before divide? Parentheses do. Remember how I keep saying there's big parentheses around the bottom part? So if you tried to get this part to cancel first here, you're wrong. You get it marked wrong. Have to have it in the right order. And the parentheses that are there force this part to be first, and the 3's cancel first. Then you have 2 over x, and again, you can't just go doink, doink. There is no canceling like that goes like that. But you can go like this. That's equal to 2 times, flip it, x over 2, and then you can cancel them. Final answer is x. Okay, you can't just say, well, I got x at the end. You got it. The work is what it's all about. Algebra. Can you do it in the right order? Okay, let's move on. This is the hardest kind, where they have an f of x and a g of x, and they multiply them or add them or times them. Do you remember the domain things with these? Okay, there are number lines that overlap. You remember that? Okay, on this plus kind, do you remember it's just the two parents that overlap? So it's the domain of f and the domain of g to get that kind. Know what I'm talking about? Okay, how about if it's a divide? Then there's not just two number lines, there's three. And it's still f and g, and then there's a third one, which is that what? G cannot be 0. And that's different than g can't crash. G can't crash is this one. G cannot be 0. So this is g right here. What would make it equal 0? Not what would make it crash. What would make it equal 0? 2. So we'd have an extra number line here where it can't be 2. All right, and then this third one here is f of g of x. That one has two number lines again. What do I overlap? Domain of the inside with the domain, oopsie, I said the big C, domain of the composite. All right, why don't you try this one, now that I've given you that warm-up for it. Try to answer what is, how about just give me the domains, because the other parts are pretty easy. If it says to add them, I just add them, and I don't have to find a common denominator because there's that square root thing. Dividing them really wouldn't be too hard either, so just try finding the domains, please. Pause for a second while you're working. All right, I'm back with you. So, the domain of f. Here's f. Domain means everything works except what? What doesn't work? All right, -7. So I have a -7 here that won't work. All right. How about domain of g? Well, everything works except negatives. So how do I keep this from being negative? X minus 2 greater than or equal to 0. X greater than or equal to 2. There we go. So here's 2. Empty spot. Greater than or equal to that. So it can be equal to 2. All right. And the last one is it can't be 2. All right. So my 2's should really line up better here. Make my 2 right here. Can't be 2. Says though, right here, because if I put a 2 in there, it'll make this 0. So that's an empty spot. So now it could be this way or this way according to the rest of that. It's just only 2 that messes it up for perspective of making g 0. All right, so this is to find the triple number line. This answer would be from 2 to infinity, not including 2. All it would take is to have that be a bracket and you'd have it wrong. Raise your hand if you had that one right. All right, a lot of people probably goofed the bracket thing. Okay, then the domain of the inside one. Which one is inside? Well, G is the one on the inside. So that's this guy's domain. That's the domain of the inside. So I'm going to say X is greater than or equal to 2. There we go. That is f o g o x. And see the O there? That's f of g of x. You got to get used to that symbology, whatever, that way of writing it, because you'll see that on the test. And yes, that means this, f of g of x, with the f on the outside. Okay, and the domain of the composite. The composite, what's the composite? Well, I actually have to put f in g, or g in f, sorry. G's on the inside. So this one needs to go into this one here and there. So I go empty spot plus 4 over empty spot plus 7. I got to drop in square root of x minus 2 here and here. Okay, now again, that cannot cancel because there's addition here. So you wouldn't be able to just cancel them back off. No. Okay, so then, what's the domain of that thing? The domain is whatever would make this equal. Well, everything works except whatever makes that 0. And there's no way to make that 0. But is there a way to make the square root down there negative? Well, that's the part we've already covered with this number line. So all we're worried about is the domain of this composite. So it's got no way to make it 0 on the bottom, but look on the top at the square root there, and do you get that the composite also has the same restriction? It has to be 2 or bigger, so it should be like this. The bottom line is they are the same restriction. So therefore, when they overlap, it's the same thing from 2 to infinity, but this time it's a bracket on the 2. Okay, yes? The domain is 2 things, though. It's not making the denominator 0 and any square roots that would crash it. So I did it in 2 parts. There is nothing that would make the denominator 0, but there is something I got to worry about with square root. So remember those 2 things on domain. Watch out for square roots. 2. So the square root domain is what makes this be a greater than 2. All right, let's move on. Do you remember one-to-one functions? They have passed 2 tests, the vertical line test and what's the other one? Horizontal line test. So the vertical line test, does this pass the vertical line test? Would it ever touch twice? No, so therefore it passes, therefore it's a function, right? Remember that? But if it's a one-to-one function, it's going to pass that and the horizontal line test. Does this pass the horizontal line test? No, it hits. Therefore, this thing is not a one-to-one function. All right? Would that be a one-to-one function? Is it a function in the first place? Yes, it passes the vertical line test. Then, let's try the horizontal line test. That's the harder one to kind of visualize, maybe. So here's a horizontal line. And is it ever touching more than once? So that's the key area right there. And see, it never touches twice. So therefore, it is a one-to-one function. All right. What that means is it's not only a function, but its inverse will also be a function. That's what a one-to-one function is. It's a special kind of function where its inverse is also a function. It's not just this one. There's others out there, but they have to pass both tests. If they pass both vertical and horizontal line tests, then they're special functions, which also have an inverse that's a function. Okay. And do you know Mr. Bean? I'm going to play this. I'm going to pause for a second. Okay, so if this is f of g of x, what would f of x be? In other words, what you're trying to figure out is which one got put inside of the other one. Okay? You get what I'm saying? So g of x is like what? G of x is like the inside, and therefore g of x is like Mr. Bean. Okay, so what's f of x? Bin Laden. That's right. I know it's a little bit of a stretch, but Mr. Bin Laden met his end finally. When I first did this joke, he was still alive. All right. I'm sure he appreciated it sitting in his little place in Pakistan. All right. Common denominators. Can you add those two? Because I can, and you might need to. Try it. Remember how to get a common denominator so you can add them? If you know how to do it, do it. So here's how you make it have a common denominator. You multiply the top and the bottom by what? X plus 1. That way, see, now the denominators are the same, aren't they? And if I do it there, I got to do it there. So then, if you can just be careful, the top becomes x times x and x times 1, and then there's another x over here. Okay, so put it all together. What's on the top is an x times x is an x squared. And then there's a x. And then there's a x, another x. And can those go together? Yep. So this x times x made my x squared. This x times 1 made another x. And this x made the third x. Final answer on the top is x squared plus 2x. But I'll simplify that in a minute. On the bottom, it's really common for people to get messed up in their thinking that somehow you add the bottoms. You do not. If you add 1/3 plus 4/3, you wouldn't add it and make it into sixths, would you? No. If you're adding fractions, the bottom would stay thirds. And the top would become 5/3. 1/3 and 4/3 makes 5/3, right? Same idea. On the bottom here, I would keep x plus 1. So then, question about that? I haven't put them together yet. X plus x. Why is there 2 though? There was 1 here on the left. And then there's this other one, x times the 1. Don't forget to distribute that. That's the most common forget part. Okay, x and the x makes 2x. So this should be a 2x. X squared plus 2x over x plus 1. I think we should try that again, but how many of you had that one right? Okay, that's about 1/5 of you. Let's try it again. Yes?
Why would it give you x, like, x plus x of 2x parentheses x plus 1?
All right. If I go back to the way, right there. Oh, wait, nope, there. Okay. You asked, why can't I do this first? Tell me about the order of operations in math. What has to be done first? You can't do the add first, can you? You got to go and do this multiply first. That's why I have to multiply that first, and then I can add the 2 later. So if I was going to do this, I would show you every single step. This first part right here would have just been x squared plus x over x plus 1. Then I can add it to this one. And then I'll have an x here and an x here. That's why I had 2 x's. Okay, let's try another one like that. X over x minus 4 is equal to, plus 3. X over x minus 4 plus 3. See if you can handle the simple common denominator. First of all, make it have a denominator. And then you can make them common. Pause for a second while you're working. Okay, in case you're stuck, first step was put it over 1. Second step, multiply the top and bottom by x minus 4. That way, both denominators are now the same. And now, multiply this part out first. Has to be first. 3x minus 12. 3x plus the other x over here makes 4x minus 12 over x minus 4. Raise your hand if you had that one right. All right, good. Can I factor the top? Yes, if you'd like to factor the top, we could. X minus 3 all over x minus 4. But that's not any better than what I had. Both of those answers are okay. Bottom you keep the same. I wouldn't say ignore it. The bottom is important, but don't add the bottoms. All right. Fractions and fractions. We talked about this a lot of times, but it's going to come up. So you know how to do this? Change it to a multiply by what? 5 halves. You flip that bottom one and it turns into a multiply. All right. How about that? What if it's not a fraction? Good question. That darkened one, darkened line, x over 2 over 5. So it's x over 1 over 2 over 5. And then, you don't really want to divide though. You want to multiply. So you change that to times 5 halves, and then I'm good again. 5x over 2. Okay. Here's a really complicated looking one, but just think about it for a second. Think about what would happen after you flipped. See the canceling that would happen? What's the final answer? X is correct. Here's why. I'm going to change this to times. Flip it. See how I flipped the bottom? And now see what cancels? X squared over x would change, it's like xx over x. One of them cancels. Final answer, x. X over 1 would be fine, but x is better. All right. I think we've done enough practice. I'm worn out on these. If I only asked you, how many number lines would I need to get this domain? How many number lines would I need to get this domain? 2, and they are domain of the inside and domain of the composite. Good. And decomposing. So, if this was the function f of x of g, f of g of x, then what was f of x, or what was g of x? And I suggested you always start with the g of x, the inside one. You just grab something from the inside. What would make sense? I agree. Make that the g of x. And then this has to become what? X. So then it's 3x squared minus 4. Those are easy, yes. Okay. That's all we got for review. Your assignment is coming. Do it, check it, take it seriously. Not an easy test.